Thank you for talking with us, Dr. Mason. Can you tell me about your title and what you do?
So I'm a sports and exercise medicine physician. So basically that means in addition to my medical degree, I've got fellowship training in dealing with athletes and other issues like that. And I guess a part of my practice is, while I deal with elite athletes, I deal with general members of the public. So, I mean, as you understand, when it comes to elite athletes, even just a 1% improvement in performance can be the difference between getting a medal and not finishing on the podium at all. So athletes are very, very concerned about human performance. So I guess this specialty that I'm in lends itself very well to optimising our health, because at the end of the day, our physical functioning is a reflection of our underlying health. You cannot function optimally if you're not otherwise metabolically healthy. So I guess that's led me to having two interesting parts to my career. So in one aspect, I'll deal with elite athletes, and the other aspect, I'm dealing with members of the public, and we're just looking at trying to optimise every facet of their health, metabolically, autoimmune, inflammation-wise, focusing on sleep and mood, and we really look at the whole package.
The three main sources of energy in the diet are carbohydrates, protein and fat. How important do you think each of these are?
So yes, it's absolutely correct. We get energy from three main sources in our diet, from carbohydrates, from protein and from fat. But only two of those, the protein and fat, are what considered essential nutrients. So the lowest level of carbohydrate intake that is consistent with good health is exactly 0. That quite literally means you can be in excellent health and not eat a carbohydrate at all. And the reasons are simple, because if your body does need sugar in the form of glucose for whatever reason, it can actually make it through a process called gluconeogenesis. And when we have a look at some of the old guidelines that actually recommend you need 130 grams of carbohydrates a day for your brain function, well, the origin of that myth actually stems from an Institute of Medicine report that actually calculated that the brain, if it wasn't given any other nutrients at all, if it was only given carbohydrates, that it could burn up to 100 grams of carbohydrates a day. And they just added on the extra 30 grams as a bit of a buffer. But the simple fact is that if you're getting enough protein and enough fat in your diet, your brain can survive perfectly happy for the most part on ketones, which are produced when fat is metabolized. In actual fact, we know that 70% of more of the energy requirements for the brain can be provided by ketones. And the rest of it can simply be provided when your body actually makes glucose through this process called gluconeogenesis. There is absolutely no need to ingest carbohydrates to be in good health.
If we do not need to eat carbohydrates to be healthy, how much protein and fat should we aim to consume?
Well, most dietary guidelines recommend an intake of about 0.8 grams per kilogram of body weight per day. And in actual fact, when we look at the literature, we find that probably about double that or even more is actually required for optimal health. And the reason that the guidelines actually underestimate the needs for optimal protein is that protein has two jobs in the body. It's used to build stuff, so things like muscles and bones require protein as a structural substrate. But it's also involved in things like enzymatic activities. So enzymes are little proteins that help chemical reactions along and do things in our body, and they're very important for our function. But in the original analysis, when they were trying to calculate exactly how much protein we need, they didn't actually consider the role of proteins as enzymes and all their myriad of important functions. They only looked at it as a building block for the tissues. And as a consequence, they severely underestimated the level of protein, which is consistent with good health. And as we know that plant proteins are also clearly inferior to animal proteins in the basis of their digestibility and bioavailability, they don't contain the same amounts of essential amino acids, and they don't contain the right concentrations of the other amino acids to be fully incorporated into body tissues effectively, or as effectively as the animal protein. So if we consider that protein intakes on certain, say a vegetarian diet might actually necessarily be lower, then that can actually, and the protein is not as good quality, then we end up with less lean tissues, less bone density, less muscle mass, these kind of tissues which are associated with good health. And then when it comes to fat, well, historically, and this relates back to the diet-heart hypothesis, we've become fearful of fat as a nutrient, especially saturated fat. But the actual fact is that animal foods which contain saturated fats are healthy, and the saturated fats in and of themselves actually seem to be good for us. In actual fact, it's the polyunsaturated fats which are found in the things we call vegetable oils, which come from seeds, which are quite deleterious and bad for our health.
I've always been taught to avoid eating saturated fats. Can you explain why you believe saturated fats are healthy and polyunsaturated fats are not?
So, it's probably difficult for your viewers to get their head around the fact that I'm saying animal foods with all their saturated fats are healthy. But the thing to understand is that that's exactly what the science shows, that saturated fats are good for us, and the polyunsaturated fats, which are found in vegetable and seed oils, are actually quite dangerous. They can actually damage our health. And the reason I can say this is because I'm backed up by the science. Now, the big problem is that while we've got science that very clearly shows this, it hasn't been communicated accurately to either the medical profession itself or to the public. So if I give you an example, so if we have a look at some papers here. So this study here was published in 1966, and it was a study of over 1 million Indian railway workers over 5 years. And they compared railway workers from different parts of the country. And the thing to understand about India is that geographically there's significant variations in dietary consumption. In the north of India, they tended to consume about 19 times more fat, most of it which was saturated animal fats. And in the south of India, they mainly get their fats from vegetable and seed oils. And the difference in deaths from heart disease between these saturated fat-consuming northerners and the southerners was 7 times. The southerners, with their vegetable oils and less saturated fats, were dying at a rate of 7 times from heart disease that of the people in the north. Now, this is what we call an epidemiological study. So it doesn't in and of itself prove causation, but we do have a bunch of other studies called randomised controlled trials which do. If we, for instance, have a look at this paper, which was published in 1965, this was a randomised controlled trial which actually had 3 arms. 2 of them were comparing a corn oil, a vegetable oil, to no oils. Basically a control diet, just continue having your usual saturated fat. In the group that was placed on the vegetable oil diet, the corn oil diet, over the course of the study, they had 5 deaths. In the group that did nothing, they had no oils, so it's just a standard saturated fat, the diet they were usually doing, they only had 1 death. Now again, this is quite old research and not great numbers, but the authors of this paper concluded that corn oil, as that form of vegetable oil, should not be consumed. And then we have a lot of more modern studies as well. We have large-scale randomised controlled trials. This one here was done in Sydney. So this is called the Sydney Diet Heart Study. This was run between 1966 and 1973. And they basically took males who had had a heart attack and they randomised them to either replacing some saturated fats with vegetable oils or not. And this study, you'll recall, was finished in 1973. But the results of it, the full results, were never published until, and this paper here, so they weren't published until this was published in 2013. So an independent investigator uncovered the original study data in a basement and went through a rigorous process of analysing the data. And when they analysed it, they actually found that the mortality rate for the group that was given the vegetable and seed oil actually increased by 62%. This is a large-scale randomised controlled trial over a number of years, and yet the data wasn't originally published. It was, decades later when it was actually published. And if you have a look here now, if you come and have a look here, we can see that this is the intervention group. This is the group that was given the oil. This is the control group that still had their regular intake of saturated fat. And this is the death rate along the side. So the higher this line, then the worse the outcome. And you can clearly see that there's more people dying in the vegetable oil group than they were in the saturated fat consuming group. Now this kind of data has basically been buried, and it's not the only one. We have the Minnesota Coronary experiment, which ran between 1968 and 1973. Over 9,000 subjects, males and females, and it was very similar. They, gave some people vegetable oils and other ones that didn't. And the results weren't published after the study completed for 16 years. And even then, they didn't publish the data on mortality. And when they actually asked one of the original investigators before he died why they didn't publish the data, he said, and I quote, it was because they found the results disappointing. So this is hard evidence that was basically hidden from the public for decades. And it's finally been published in 2016 in the British Medical Journal, a very reputable journal. But don't think for 1 second that this kind of, misrepresentation or hiding of results is confined only to previous eras. We still have it in the modern era. You may have heard of the Women's Health Initiative study. This here cost over $700 million US. They followed 48,000 females for about 8 years. This was a big, massive study. And yet, when we look at the results when it was published, if we have a look at the conclusions, no statistically significant findings. If we flip through to the results tables, we don't find any statistically significant findings at all. But it's only when we go to page 661 of this study, in one sentence of obscure text, which I've highlighted here, do we get the truth. This is the only statistically significant finding in this study. And what that means is that when we do a study, we can sometimes get findings that are likely to be due to chance. So we have to do mathematical calculations to work out what that probability is. So if we get a finding that's called statistically significant, then we say this finding is not due to by chance, it's what we call a real finding. And this study only had one of those findings. And that was that females with a history of heart disease, if they went on a low-fat diet, their chance of complications of things like heart attacks was increased by 26%. That was the only significant finding of this study. And it was basically buried on page 661 of this journal. It was never discussed in public by the study investigators, wasn't mentioned in the conclusion at all, and didn't even get into the results tables, which is where most of us, when we're reviewing articles, will go to the results tables. They just left it out. So don't think for 1 second that science has never looked at whether saturated fats are safe or whether seed and vegetable oils are potentially harmful. We have a clear abundance of evidence that they're not good for us. Fortunately though, science is now catching up. So the American College of Cardiology earlier this year published this state-of-the-art review on saturated fat consumption. And after a complete analysis of all the literature, they've actually concluded that we should freely consume meat, eggs and dairy and not worry about the saturated fat. Now this is an organisation that used to be heavily in favour of controlling fats in the diet and going on low-fat diets. So this is actually something of a watershed movement, and I'm actually significantly heartened by this, because one of the major reasons that we've actually seen vegetarian and vegan diets pushed so strongly through scientific and medical circles is through this fallacious belief that saturated fats are dangerous. But now that some of the true evidence is trickling down and filtering through, we can actually see the truth of that people who consume a lot of saturated fats do not impact their health negatively at all. In actual fact, it's the vegetable oils and the seed oils which seem to be doing the damage.
Several studies have been published that link longevity with diets that limit meat consumption. Can you explain why people living in these blue zones seem to live longer?
So a lot of the research that we have on whether meat-free diets or low-meat diets are actually beneficial to the health are what we call epidemiological studies. And epidemiological studies are fundamentally flawed in that they can't prove causation. That is, they can't prove that something happens. All they can show is that two things occur at the same time. So for instance, people in the blue zones, if they believe that not eating meat, so if we take the Loma Linda group who believe that not eating meat is a healthier diet, well, they also engage in other health behaviours. They have a big focus on community and family. They're very low rates of smoking, not abusing alcohol, all these things that also contribute to good health. So how confident can we be that any health benefit we actually observe in this population is due to the lack of meat when you've got so many other confounding factors? We also see Okinawa, we take areas like this with the blue zones, and there's now very reliable research that shows that a lot of the information about how old these people are is actually very unreliable. And it's very, very likely that the ages and the lifespans of people within these areas has been significantly overestimated. And we also see that in Okinawa, that as meat consumption is reducing, it's not actually conferring any benefit to all-cause mortality. And then there's the obvious elephant in the room. We have countries like Hong Kong, which is the highest meat consumers in the world. They also have the longest life expectancy in the world. So if we're comparing, we look at data like this and say, well, it just doesn't make sense. If we take a group like Loma Linda, which has got about a population of about 24,000 people, very, very small population, compare it to a whole country like Hong Kong, I know which data is more reliable. And we're also ignoring, well, what about the Mormons who do eat meat, but they actually engage in other behaviours, in terms of non-smoking and these other things? Well, their lifespans are very, very similar to what we see in Loma Linda. So we really can't put a lot of trust in this epidemiological research. And even when we can, well, if we could, we can't put a lot of trust in this epidemiological research. And even then, some of the epidemiological research doesn't always show in favour of reducing meat consumption. So it's almost accepted now that meat consumption causes bowel cancer. That's just something that people believe. But in actual fact, the evidence for this is incredibly tenuous, and the evidence actually goes in the other direction as well. So we have this study here, it's called the EPIC trial from Oxford University, and this actually found that the rate of bowel cancer in vegetarians compared to meat eaters was increased by 39%. Now again, this is only epidemiological evidence, so it doesn't prove causation, but it certainly should give us food for thought when it comes to whether or not we should actually trust a lot of this research that claims that meat is bad for us.
Some carnivores claim that after changing their eating habits, they lost weight and healed the disease. Do you believe that only eating meat can be healthy?
Yeah, this is a very interesting question, and I guess people who are on the carnivore diet who I see as patients, they get two benefits from it. So the first benefit is that inherent within some diets, there are certain chemicals and proteins that people react adversely to, and it's simply a matter of removing those chemicals from the diet. So that could be something called lectins, which is a certain kind of protein. There could be phytates or tannins or oxalates, and there's a whole laundry list of things that some people can react to. But I guess the question that most of your listeners will be interested in is, what about the nutrients? Haven't we been told that we need to eat vegetables for the nutrients? Well, the fact is, vegetables on average are less nutrient dense than animal foods. They just don't contain as much nutrients. So for example, if you were on a purely vegan diet, eating only vegetables, without supplementing, you would end up getting very, very sick due to deficiencies like B12 deficiency. So I would ask, is a diet that you have to supplement on to stay healthy, to stay alive, is that really nutritionally optimal? And do we see this with people on carnivore diets? We don't actually see people. Most patients I see who are on the carnivore diet actually don't supplement at all. And when I look at their results, we don't see evidence of nutrient deficiency. Now, the most common one that people will cite is vitamin C. They'll say, oh, but you must have some fruits and vegetables because you'll lack vitamin C. Well, vitamin C is very interesting. So first of all, molecularly, it's very, very similar to glucose. So when you ingest vitamin C, it's actually competing with glucose to get into the cells of your body. So people on carnivore diets who aren't consuming the glucose in the first place, they actually absorb more of the vitamin C. And what a lot of people don't realise is that animal foods, including meat, contain vitamin C. And this has been known historically for a long, long time. So in the Napoleonic era, one of Napoleon's armies in Egypt, they used to use horse meat from horses that were killed in battle to cure scurvy. It's been well known. Antarctic explorers, they well knew that if they consumed penguins, then that would prevent scurvy. So this has been known. This is not new science. It's just not well known. We know that if we actually do an analysis of meat, we actually do see it contains vitamin C in necessary amounts. And this is another area where science has been poorly done and poorly communicated. If you go and look at a table of the nutritional quality of meat, you might often see that it says vitamin C 0, but it will often have an asterisk. And when you look at that asterisk, you'll go down and in fine print, you'll see assumed value, not actually tested. So it's this mistaken belief that meat mustn't have vitamin C that led to a lot of scientists not even actually bothering to test for it. So the simple fact is that we can get all the nutrients we require from animal foods. If we take eggs, for instance, they are nature's multivitamin. Contained within each yolk is all the nutrients required to support life, to support a living organism. You can't say that about a single vegetable. And if we actually have a look at some of the science, there was this study that was done in Ecuador, that was published in 2017, and they actually found that as a randomised controlled intervention, by giving infants just one egg a day, they were able to reduce the incidence of underweight children by 74%. So animal foods are incredibly nutritious, especially when it comes to plant foods. We know that plant foods, for all intents and purposes, are deficient in nutrients.
Vegetables have micronutrients, antioxidants and vitamins. Can we get the perfect nutrients for our body by eating animal products only?
I think the key thing to understand is that the nutrients in plant foods, first of all, they're less nutrient dense, and the nutrients within them, by and large, are much poorer qualities. They're less absorbable and they're less bioavailable. So this includes things like even omega-3. So if we have a look at the ALA, which is a precursor to the active forms of omega-3 in the body, less than 5% is actually converted into the biologically active forms. The plant source of vitamin A, for instance, is probably about 12 times less biologically active than the animal form. So we see the forms of iron, so heme iron versus non-heme iron. It makes a massive difference. And even then, even if we are consuming nutrients, there's other factors in plant foods called anti-nutrients, which can actually block their absorption. I'd like to show you this paper. So this paper was done quite some time ago, and it was published in 1979. And if you have a look at this graph here, this shows how much zinc is actually being absorbed into the body after consuming 120 grams of oysters. You can see that we get quite a good amount of zinc that actually gets absorbed and ends up in the circulation. Now, what happens if you combine that same amount of oysters with 120 grams of corn or tortillas? We can see here the bottom line. The absorption of zinc is basically stopped. So this is called an anti-nutrient effect. You have this much zinc, which is, call the area under the curve, which will give you how much is actually entered into the circulation, versus basically zero. And this is these anti-nutrient effects are real. So if you're looking at a label, and let's say you had a packet of corn tortillas and they had added zinc to it, do you really think that added zinc is going to be beneficial if your body can't absorb it? And we know that plant foods, say tea for instance, can impact your body's ability to absorb iron. The nutrient quality of plant foods is far, far less. So if we look at it in its entirety, number one, that animal foods can contain all the nutrients that you need, that phytochemicals, plant chemicals, actually don't serve a part of human physiology and they're very poorly absorbed anyway, and the anti-nutrients in plant foods can then block absorption of healthy nutrients anyway. You can see you've really got a triple whammy. So when it comes to nutrition status, it's absolutely true that animal foods are best. And don't think that this doesn't have very real consequences on people. So if we take the most common nutrient that everybody always talks about in terms of vegetarian diets, it's B12, because we know that animal foods really don't contain any B12. But every vegetarian, almost, I'm sure, knows this. So they must be supplementing with it. So if there was a nutrient of concern that shouldn't be an issue in vegetarians, it should be B12, because they should all know to supplement with it. And then also from the EPIC Oxford study, we have this kind of paper, which shows that we have a massive rate of B12 deficiency. So this study found that 52% of vegans were deficient in B12, despite, I'm sure, almost all of them knowing that it was something that they needed to supplement with. And don't for a second think that this doesn't have real issues. This is a systematic review that when we look at the more modern assays of B12, we find that if you're low in B12, it affects your intelligence, it affects your cognition, how your brain functions, increases the risk of dementia. This is very, very real. We know that iron deficiency is very common because the non-heme iron we have in vegetarian foods is really not very well absorbed. So this study actually looked at females who had iron deficiency and then looked at what happened to their intelligence if they were able to correct that iron deficiency. So if we have a look here, you can see here that in terms of their learning, their memory and their attention, these grey bars here were in those females who they improved their iron levels on in their blood. You can see they literally increased their intelligence by replacing iron. We take another supplement called creatine. In meat, this is naturally present. In flesh, this is naturally present, but it's not naturally present in plant foods. And we've got randomised controlled trial level of evidence that supplementing vegetarians and vegans with creatine improves intelligence. This is the best level of medical evidence we have. We can't pretend that the nutrient deficiencies within vegan and vegetarian diets aren't having a real impact on people. We know that in young children, vegetarian children, they are deficient in these nutrients, and this affects them for their whole lifespan. It affects their intelligence, it affects their growth. We've already talked about how we can reduce underweight children by 74% simply by supplementing with 1 egg a day. That's a massive improvement. If we're trying to have healthy, robust children that are growing, their brains are developing, they absolutely need animal nutrition. It's just madness to think that any other diet is going to be optimal.
If we eat carnivore with lots of protein and saturated fat, won't this be detrimental to our health?
The reason a lot of people are concerned about animal foods is because they're rich in saturated fat, but they don't just contain saturated fat. And as I've already explained, saturated fat is not deleterious in any way. It's actually very, very healthy. But the interesting thing is when we come to the polyunsaturated fats, the omega-3s and the omega-6s, because their chemical structure means they're very prone to something called oxidation stress. It means they contain double bonds which are reactive. And if these fats oxidise before we consume them, they actually generate oxidative stress in the liver and can contribute to problems like insulin resistance. And we've actually measured this when we do studies and we give people vegetable oils, which we know are heavily oxidised. We can actually measure these oxidised components in their blood very shortly after consumption. The beautiful thing about animal foods is, though, that we wouldn't eat them if they were off, if they were rancid. So the definition of rancidity is basically when the fats oxidise. So if these monounsaturated and polyunsaturated oils, called oleic acid and omega-3 and omega-6, they are essential to good health. But if we get them from meat sources, we're getting them so they're not oxidised, assuming that they're fresh, and they actually are essential, they're actually healthy for us. Whereas if we get those same oils and same fats from, say, a vegetable oil, the chances are, because these things oxidise within a matter of days, chances are that they are heavily oxidised and they'll be doing us damage. And that likely explains why the Sydney Diet Heart Study, the Minnesota Coronary Experiment, the corn oil study, all these studies actually demonstrated harms of vegetable oil consumption. So yes, meat is very rich in fat, but that's a good thing. It provides us with all the fats we need, saturated, monounsaturated and polyunsaturated, and the best thing is in fresh meat, those fats are not oxidised, they're not doing us any harm at all.
Most carnivores report having high LDL cholesterol levels. Isn't that a problem?
So I see a lot of patients who are concerned about their LDL levels because they've gone on a ketogenic or a carnivore style diet and their LDL levels have increased. And invariably, they've been told by their other doctors that it's going to be causing them harm, that it's going to increase their chance of an early death. But when we actually look at the evidence, this isn't actually borne out. This was published in 2016. It's a systematic review of 19 studies, prospective studies, that looked at mortality and LDL levels. And of those 19 studies, 16 of them, representing 92% of total participants, found an inverse relationship. Basically, this found that the higher your LDL level was, the more likely it was for you to live longer. And this absolutely flies in the face. But this is a very good paper. This is a systematic review of prospective studies published in a top journal. So in terms of, am I concerned about my patients' LDL levels if they go high? Not in and of itself. We always have a look at the other metabolic risk factors. We have a look at other parameters that will actually give us far more indication of their real cardiovascular risk. LDL, for all intents and purposes, does not serve that purpose.
What about fibre? Isn't eating fibre necessary for intestinal health?
So the thing about fibre is it only comes from plant foods. So there is no fibre in any animal sourced food. So this is really, I guess, making the argument, well, is it possible to be carnivore or not, or will you get constipated? One only ever has to change the nappy of a breastfed infant to know that you don't need to consume fibre to open your bowels. Fibre is absolutely not essential for regular bowel habits. And in actual fact, there's evidence that shows that fibre might even cause constipation. So if we have a look at this paper here, this was published in 2012. And this looked at symptoms of constipation. So they had 63 subjects who all had constipation. And they trialled them on various types of diet, ranging from zero fibre diet all the way up to very, very high fibre diets. And so in the arm of the study, where they had zero fibre diets, the subjects were advised to eliminate all vegetables, all fruit, all cereals, whole grain bread and brown rice from their diets. And all 41 subjects who went on that zero fibre diet had complete resolution of all of their symptoms of constipation. This was pain, bleeding, bloating, strain opening their bowels. They did better. So, and this was highly statistically significant. This finding was not due to chance. So the best evidence we actually have is that fibre actually exacerbates symptoms of constipation. And I see patients in my clinic every week who tell me this, that they've had stomach problems, they've been told to increase the amount of fibre they ingest, and it's just made their symptoms worse. And this is such a simple intervention. And it really goes against common thinking. But if we think about it, constipation is really trouble passing something through a small hole through the anal sphincter. And we know about fibre's ability to bulk or increase the mass of the stool. So does it really make sense that increasing the size of something is going to make it easier to pass through a small hole? I mean, that's really like adding extra cars to a traffic jam and thinking that somehow those extra cars are going to clear the traffic jam. It's just going to make the jam worse. Now, the other thing when we talk about gut health is something we call the microbiome. And there's a lot of unscientific claims being made about the microbiome in advance of the science. But what we do know is that some microbiomes are associated with improved metabolic health. But the key here is that they're associated with it. They're not causing it. So about 90% of the bacteria in our colons are made from one of two phyla, Bacteroidetes or Firmicutes. And we know that a larger amount of Bacteroidetes and a reduced amount of Firmicutes is actually associated with improved metabolic health. Now, when we actually put people on ketogenic diets, we actually see that very pattern. Increased Bacteroidetes, reduced Firmicutes, good metabolic health. Now, is it more likely that the good metabolic health comes from the fact is that you're now on a healthy diet, or is it somehow magically due to the microbiome changing? It's absolutely not the microbiome. We can change the microbiome within 24 hours. We can get wholesale changes within 24 hours. It's just coming along for the ride. So yes, it is reflective of the type of diet you're eating, but it's not causative. The real bang for the buck, the real benefits come from the diet, and then obviously the food that you eat also feeds the bacteria, and different bacteria in the gut will proliferate differently depending on what food you're eating. So this is really where a lot of people have mistaken correlation for causation. Just because two things occur at the same time doesn't mean that one causes the other.